Okay, you guys, we're going to finish up the rest of the notes for this chapter. There's not a super lot of slides, so I'm going to go through them. And then I have another PowerPoint that actually goes through significant fit better. It shows you some problems and things like that. So this will be a real short one, and then I'll have another one on significant figures. And then after that one, I'll have an assignment, not so much for this one. But anyway, we already talked about significant figures a little bit. Whenever you take measurements and do calculations with those measurements, you use significant figures. And again, it's just a way of making sure that you don't overstate your accuracy. You're not lying. You're not reporting measurements, calculations that are way more accurate than the measurements you took. And that's why we use significant figures. So anytime you calculate something like density or specific heat or anything like that, you have to use significant figures. Okay, so which ones are significant? Well, all non-zero numbers are significant. So 1 to 9, those are all significant. Zeros in between. So like if you have 101, that zero is significant because it's in between. Zeros at the beginning of a number are never significant. So if you've got like a number less than 1, if you have 0.0009, those zeros aren't significant until you get to the 9. And then zeros at the end of a number are significant if a decimal point is written. So if you want to make numbers more significant, let's say you take a measurement and it just happens to fall on 0. If you want that 0 to count, you need to write a decimal. Okay? If you don't, it's like an estimation. So decimal points are really important. And you always count the zeros if you have a decimal. Basically what it means is if I took the time to write the decimal, I measured up to that point and it just happened to fall on 0. Okay? Whenever you add or subtract with significant figures, you have to make sure when you get done with your answer, let's say you take something that has goes 1 past the decimal and you have another one that goes 5 past the decimal. Add it like you normally would or subtract it like you normally would and then round it. If it only went 1 past the decimal, the one that goes least past, then you'd have to round your answer so it only goes 1 past the decimal. And like I said, I have a PowerPoint. Well, I'll give you examples and show you this, but these rules are in your book if you need to go through them again. Okay, when multiplying and dividing, it's the number of significant figures. Okay, so if you take something that has 9 significant figures and you multiply it by something that has 2 significant figures, your answer can only have 2 significant figures. So you have to do some serious rounding. This is when it gets crazy. Like if I ask you what 4 times 4 is in significant figures, it's not 16, it's 20. 20, no decimal. And don't tell the math teachers I told you that, but that's how it works with significant figures. Okay. Another thing we look for in measurements is accuracy versus precision. Okay. If you're accurate, and sometimes we check these. Okay. Accuracy means how close are you to the right answer? Okay. If we're finding density of a bunch of materials, they have a set density. So you find the density of aluminum and you get 2.9 and the actual is 2.7. You're sort of close, how close? The only way you can determine your accuracy though is if you actually know the right answer. So, you can't always determine the accuracy because sometimes you don't know what it is. Sometimes, and then another thing we look for is precision. Okay, if you take 10 measurements and you're doing the same procedure each time and they're close to each other, then you have good precision. That doesn't mean necessarily that you have good accuracy. If you take a bunch of measurements and you get 1.2, 1.25, 1.2, 1.27, and so on, and the right answer is 4, you had good precision, you didn't have such good accuracy. Basically what that means is whatever you're doing wrong, you're doing it wrong consistently. Okay, so if you look over here, sorry, I'm covered us up a little bit. If you're talking about darts, if you get the bullseye on all 3 throws, you had good accuracy, you hit the bullseye, and you had good precision because all 3 darts ended up there. On this one, they had good precision because all 3 darts ended up in the same area, but not so much with the accuracy because you didn't hit the bullseye. And here where they're all scattered, they're not either. You don't have precision, they're not near each other, and you didn't hit the bullseye, so you don't have good accuracy either. Excuse me. Whenever we're solving problems, we use what they call dimensional analysis. It's a simple way of converting one quantity to another. You use conversions, like here, we're changing meters to centimeters first and then to inches. Okay, it's easy to convert meters to centimeters. You just move it over 3. And then 1 inch is 2.54 centimeters. So you need to use conversions. And when we start doing these conversions, chapter 3 is where we really hit dimensional analysis. I'll show you again how to do these. But really, I'm just taking meters and changing it to inches. They equal each other. So whenever we use a conversion factor, we're just basically multiplying by 1. Okay. And here they show when we're doing changing inches to centimeters or centimeters inches, we use 2.54. That's the conversion. Which way you use this, whether you use it this way or this way, determines on if I'm starting with centimeters, I'm going to use this one because I'm going to put, I want my centimeters to cancel each other out. If I'm starting with inches, then I'm going to do this one because I want my inches to. So you always want whatever you start with, when you do your conversion, that should be on the bottom because they cancel each other out. Okay. And whenever you're doing dimension analysis, you're going to start with something. It's going to give you an answer. You're going to put that unit on the bottom, and then what you're trying to find, you're going to put on top. Sometimes it's just one step. Sometimes it's several. It depends on what you're looking for. But whatever you start with, the unit you start with is what you want on the bottom. This conversion factor, again, is like multiplying by 1. Okay, here's an example of changing 8 meters into inches. Start with your 8 meters. Well, meters on the bottom is 100 centimeters. And then if I convert it to inches, again, I want centimeters on the bottom. I know 1 inch is 2.54 centimeters. And then I just take 8 times 100, and then I divide by 2.54. You can multiply by 100 and divide by 100 if you, by 1, excuse me, you guys, but you don't really need to. So you take 8 times 100 and divide by 2.54, and you get 315. And then you look, meters cancel out, centimeters cancel out, inches are left over, and that's what I'm looking for. That's an example of a dimensional analysis. Okay, so that's it for this one. And again, I'm not going to have any activity afterwards this. That's really bad. After this little part, I have another one with significant figures that goes into more detail. That's the one. So this one you just watched, take notes if you must, and then I'll hit the next one, and that's when you'll actually do a quiz. All right, that's it for this one.